What's going on, tech fans and AI stakeholders? Even though the context window has grown, the depth of inference and cognition of LLMs still leaves room for desire. I've been working on building a truly useful personal assistant, one who understands my intentions, can parse reference material about my past in a relatable way, just overall be, and here comes the cliche, a Jarvis style, super intelligent, super insightful, accountability partner and assistant. What everybody's been craving since they told us AI had arrived. See, I've been building and uploading these massive single shot prompts since before you could even upload rules or steering files, like all the popular players have enabled for us all to enjoy these days. What I used to do was draft a detailed one-shot prompt document with few shot examples embedded, and then I would just add a top-line query or task and paste the whole thing into the chat window of whatever LLM chatbot I was using at the time, mostly ChatGPT. And I was getting some decent results with it, so that became my practice. As the capabilities of the LLMs evolved, so did my processes, until my curated instruction docs started getting as big as 1,000 lines plus. What I noticed was that some of the instruction would simply not be followed by the LLM. Direct and specific instructions would just go unanswered, partially depending on where it was located in the prompt mostly. If it was buried, you might as well forget about the model following the instruction. This time around for my AI assistant, I had to figure out some kind of countermeasure, some way to make this less pronounced. So I spent about a week tweaking and reading until I understood the underlying reason and came up with a novel solution, I think, to solve the problem, essentially. After I fixed this problem, it cut my token usage by 63% just as a byproduct. I was really looking for the accuracy of the model's ability to follow my instructions. That was my chief goal, but I got some other benefits out of it, right? If you building anything serious with LLM agents, assistance, or automation, anything that requires long form, detailed instruction, which by the way work best with LLMs, you're gonna hit the same wall I did. Your prompts get bigger, your results get worse, and very few out there can tell you exactly what the hell is going on, right? Today, I'm gonna show you exactly what I experienced and how I fixed it. And so here's what I found. I've been building Nathaniel, a personalized AI assistant, not a simple chatbot. This thing's got behavioral frameworks, crisis protocols, specialized knowledge bases, decision trees. I've been working on this for a while. It started just as a few dozen lines and has evolved to now over a 1,500 line, carefully crafted instruction document that any LLM should be able to follow. In the beginning, it looked like it was working just fine. I liked it. I was getting results. But as the system grew, the instructions started getting ignored. Not all of them, just the ones buried deep in the document. At first, I thought it was a prompt quality issue. Maybe my instructions wasn't clear enough. Maybe I'm doing something wrong with the instruction. Let me try some different things. So I rewrote them, same problem. Then I thought maybe it was the model. So I tried different models, same problem. That's when I started digging into what actually is happening under the hood of this thing. And here's what's going on. LLMs chunk large prompts when they process them. They have a finite reading context window, and when they hit that, the information will start to get truncated. And so the geniuses, way smarter than me, thought of an idea to build in a mechanism to solve for that, and that was chunking. So the model will read a chunk of text, and I found it to be around 500 lines of text. And then it has to stop there and then chunk it and then start the next chunk. Otherwise, information will get truncated. So it'll take the first chunk, process it, take the second chunk, process it. And that's how it's supposed to work. But the problem is the model often starts generating a response right after processing the first chunk. It doesn't even consider the information it picked up in the other chunks. It just starts working on the answer based on the information it got from the first chunk. And that was my experience consistently enough to where I figured I needed to do something about it, or at least find out what was going on and try to develop countermeasures to solve for it. Before it could even see the critical information that's buried later in the document, it would just start answering the question and completely ignore the rest. The thing is, I don't think that the model is purposely ignoring you or ignoring me, ignoring us. It literally hasn't seen the instructions yet when it starts responding. Traditional fixes felt like compromises. Split your document into smaller pieces. Now you're going to manage dependencies between documents and hoping the model loads them in the right order, and also still that it puts the entire document series into context rather than just, it'll read it all, but then the first document is the one that gets all the light. Typically, the only thing you could do was just load everything every time, which was slow, expensive. You burning up context window, you burning up tokens on context. That's not even relevant to the current request, whatever you're trying to get it to do. Simplify your prompt, you say? Sure, but then you lose the compatibility you built in the first place. None of these ideas felt right. So this is what I did. After thinking about any possible solutions I could while I was out on my morning walk, the idea just came to me. What if I put a table of contents at the top of the document and just force the model to read the table of contents to find out exactly where in the document the information is and go straight to that position in the document, get the relevant information, come back and synthesize a result for me that I can be happy with. So this table of contents ain't for you and me, it's for the model. And I was skeptical at first because I was like, I know it can't be this simple. It just can't be. But it was surely worth a try, and so that's what I did. The theory was that when the model hits the table of contents first, it will have a map of the entire document before it starts processing anything else. It should know what section exists and where to find the section, what information is contained within it. Provide the right detail and process the instruction. And after some tweaking and testing, I had something that I felt pretty good would, if not solve my problem, at least mitigate it enough where I could tolerate it. It was tolerable for whatever my needs was going to eventually be. So the pattern works like this. Instead of the model loading all 1,000 plus lines every time I ask it a question, the model would load a small core context, maybe 200, 300 lines of stuff that's always relevant in every context when using this document. Then it would match the keywords in my request to a routing table in the document, and based on that match, it would load only the relevant sections. If the request is ambiguous and it couldn't figure out what it needed to load, it would just fall back on loading the full document, right? Kind of a fail-safe mechanism. I call it Table of Contents, or TOC, dynamic loading. It was just completely novel idea. I haven't seen anything like this in the wild as it relates to context engineering and prompt engineering, with proven results where a model can actually use this as a feasible way to solve a problem and give you the responses that you're looking for. So let me show you what this looks like. Here's my actual TOC structure. Each session has a clear name and a brief description on what it is. The routing table maps keywords to sections. So if someone asks about crisis or emergency, it loads the crisis protocol section. If they ask about writing or documentation, it loads the writing guidelines section. Key insight here, and this took me a while to figure out, use HTML comment markers as the anchors, not line numbers. Something like hashtag section name at the start of each section. Line numbers break the moment you edit the document. Add a paragraph, all your line numbers shift, you lose the functionality of the document. But anchors will survive an edit because they're anchoring the sections. The section grows, the anchor still marks the outline of the section. For a living document that you're constantly updating and improving, this is everything, right? This is what you need. So trust me, I learned this the hard way. After a few weeks of refinement, here are the actual numbers. 44 to 63% token reduction depending on the request. 30 to 40% faster processing because we're not loading irrelevant content. 82% of requests are handled with targeted loading, meaning most of the time we're only loading what we need. Only 18% needed the full fallback in order to function. Real efficiency gains without losing any capability. Now, this pattern isn't for everything, right? You can use it when your document is over 500 lines, when you're not just making a query, but you're prompting AI to do or complete a specific task, because I think there is a difference and it's not really, the distinction is not really made enough. People just say prompt, prompt, prompt. There's a difference between a prompt and a query. When you just ask the LLM, what time is it or what's the weather, that is a query. When you say, I need you to go research this and give me back this kind of document on this particular aspect of some data point, that is a prompt, right? If you got 3 or more distinct sections that can stand alone, this is a good play for you because most requests only need part of a document. Now, you can skip this if your sections are highly interdependent. If every section references every other section, dynamic loading won't help much in this situation. But it does work great for PRDs, technical specs, reference documents, behavioral frameworks, anything large and modular. Now, I got the full pattern and breakdown with full explanation on my Substack. There's an implementation template. You can copy it. Take the code examples, the routing table structure, everything you need to try this yourself. The link gonna be in the description. So there you go, fam. TOC dynamic loading, map first, load smart, and save tokens. Without this pattern, you're burning tokens and you're getting worse results as your prompt grows. With it, you get the capability you built without the cost. I'm gonna be documenting new patterns like this one as I continue enhancing Nathaniel, who is really showing out already. I'm really astonished. Like, wait until you see what this is. Wait until you see how Nathaniel behaves. I'm doing a case study eventually when I'm done, and I'll have a video for it. It's gonna be it's gonna be awesome, okay? In the meantime, I'm building AI systems that cannot fail, and I'm sharing what actually works in production, not just in the demos. So subscribe if this is going to be useful to you, and let's chat about it in the comments. What patterns are you using for large prompts? What have you seen out there in the wild? What's working, what's not? Drop a comment. I'm genuinely curious about working with other builders. Until the next discussion, Tech Fam, keep experimenting, keep building, and keep cautiously embracing the future.